Hello and welcome to Maths at A-Level Geography. Today we're going to be looking at Spearman's rank and we're going to work through an example of how to do Spearman's rank but for a tectonics example. So to start us off with, Spearman's rank is a statistical test and is used in geography to see if there's any relationship or correlation between two sets of data. Now note that this formula will be provided if given in an exam question, and it's normally worth around 6 marks, so I've broke it up into 6 stages, so you get a mark for each stage. So what I've tried to do here is break up the equation for you. So RS just is Spearman's rank as a symbol, and then we've got 1 minus 6 times the sum of d squared over n cubed minus n. So what we have to do here is just break this up a little bit. So the symbol that looks like a 3 but backwards, it just means the sum of. We've then got the d squared bit, that is a column in the table of figure 1 that we're about to see, and then n in this instance just means the total number of examples that is in figure 1. So let's crack on with this. So step 1 is all about filling in the gaps in a data table. So you'll get given a table, most likely similar to this, with various gaps, and this is figure 1. If you do it column by column, it probably makes life a lot easier. So all we're doing is ranking each of these magnitudes of earthquake. So if we go to, so 9.5 is the highest rank. If we look down here, the USA Alaska 1964, that is the second highest rank. So you'd put a 2 here and then work your way through it. So 8.6. It's probably worthwhile to just check to make sure there's not any other 8.6 variables in here. So there is. So the Indonesia Sumatra 2005 is an 8.6 and they've ranked that as 7.5. So this will also be 7.5. That's our third highest rank. And then we've got Chile 1960 here, 8.2. That's quite low. It's already been done. The Russian one down here at 1969 is also an 8.2. So make sure you're checking to see if they've already been ranked, because in some instances it's just trying to catch you out. So when we do the D column, we're looking for the difference between the two ranks. So if you look at example 1 here, Chile, this is rank 1 for the magnitude, and then the deaths and injuries is rank 4. So we're just looking for that difference, so D for difference, between the ranks of each of these examples. So the difference between 1 and 4 is obviously 3. The difference between 19 and 17.5 is 1.5. So you'd put 1.5 in there. And working your way down, difference between 3 and 1 is 2. The difference between 7.5 and 13 is 5.5. Don't go into the minuses. Just keep it simple. 5.5. Keep it positives. Down here, difference between 2 and 11 is 9. And then if we do the d squared column, that is just this figure here. So the difference figure squared. So 1.5 squared is 2.25. So 2 squared is 4. 5.5 squared is 30.25. You see below here this has already been figured out for us, so I've just copied it down. And then 9 squared is 81. So now we've filled in the table, it'd be worthwhile just to mention or maybe label these important bits at the bottom. So the n equals 20, this is going to come in handy later. So this is that n cubed minus n part of the table. So this would be the figure that we'd be putting in, because there are 20 examples here. Okay. Then this part here, so you might want to write that that's the examples. So there's 20 examples. And then this bit at the bottom here, this is the total of this column. So this is the top of the equation, okay? So this figure here is the top of the equation. So the 6 times the sum of d squared column. That is the figure that we'd be putting in there. So step 2 is all about writing the null hypothesis. So this just means you completely reject the link between the two variables. So in this case, we completely reject the idea that there's any link between magnitude and injuries/deaths. So your sentence for this, you'd probably get 1 mark one sentence, there will be no correlation between the magnitude of earthquake events and the number of deaths/injuries. That would be your 1 mark. That's your 1 sentence. Very easy. So you're always rejecting that link between the 2 examples that they're trying to compare in the table. So step 3 is all about calculating the RS value. So it'd be beneficial to probably start by writing the equation, just so you've got it. So RS equals 1 minus 6 sum of d squared divided by n cubed minus n. So that's your equation. And then if you show you're working out through this, you'll definitely get marks even if your calculations are wrong. So that's really important. So just giving it a go is better than not trying at all. So try and fill in the figures. So this would be 1 minus the 6 times 546.5 figure. That would then be divided by 20. So remember we had 20 sets of data. 20 cubed minus 20. So you definitely be getting a mark for this, even if you don't complete the calculation. Then we go 1 step beyond that. So we go 1 minus. So if we figure that out, work that out, we get 3,279. And that's divided by 8,000 minus 20. And then we keep going. So remember, this is all the stages. So you do that. That goes on to that. So showing how you get to each stage is really important. And it'll really help you as well, just to get your head around this. So 3,279 divided by 7,980. Then you'd end up with 1 minus 0.41. And then your overall figure, so it'd be RS equals 0.59. So 0.59 is our RS value. So you've got to show how you get to each stage. Don't forget about this 1 minus bit. You save that to the very end. So the 1 minus the result of this division sum. So make sure you don't forget about that 1 minus. A lot of people tend to forget to include that final stage and just go, oh, well, it's 0.41, that's the value. And that's wrong. 0.59 is our value. Okay? So step 4 is all about figuring out whether or not we've got a positive or a negative correlation. So our value, remember, is positive 0.59. Now, I've drawn out this number line. You won't get this in the exam, so it might be worthwhile remembering this. Maybe just draw a really quick sketch of this when you've figured it out. So when you're figuring out the RS value, you might want to chuck this number line down somewhere just to remind you to include it. And this basically determines the wording that we use for the final stage. So 0.59 just sits nicely in this area of moderate positive correlation. So it goes weak positive, moderate positive, strong positive. So it's wherever our figure is closest to. If it's closest to 0.5, then we're looking at a moderate positive. If it's closer to 1, like the whole of 1, then we're looking at a strong positive. Okay? And the same thing works for the negative correlation. So if you're getting a negative figure at the end of your RS value, it's the same thing again here. It's weak, moderate, strong, but in this case it will be negative. Okay? But with our example, it's positive, so we're going for a moderate positive correlation. So step 5, we're comparing our value to the significance values. So you'll normally get a table that looks a little bit like this, that talks about the degrees of freedom and the significant values. So no one expects you to remember this table. This should be given to you. All you have to do is just pinpoint where our value sits in relation to this. So because ours is 0.59, even if it was a minus, the same thing would apply here, but 0.59 sits closest to that 99% confidence. So it's beyond that 0.534 figure. So we've got a 99% confidence, and this is important again for that final stage. The final stage of this is all about piecing it all together to write an explanation of the result. So a lot of people get confused when it says to explain what you figured out, explain the results. It's literally just this paragraph here that you'd have to write. So you'd start off by saying whether or not you accept or reject that null hypothesis. In our case, we're rejecting it because we said that there's no correlation between deaths and injuries, but there clearly is a relation between deaths and injuries and the magnitude of the earthquake, as we figured out. Because we've got a 99% certainty of this, linked to step 5, and then this is where we chuck in some of those words from step 4. So we say we reject with the null hypothesis with a 99% certainty that a moderate positive correlation exists between the two data sets that we've got. So in this case, between the magnitude and the number of injuries and deaths. Okay? And then we just end it off by saying this correlation, therefore, is not due to chance. And we say this because we figured it out. We figured out that statistical value. Hopefully this has made some sense of the Spearman's rank correlation test. You might want to have another go at one of these. There's plenty of examples on the AQA website from past papers. You can also obviously go and ask your teachers for extra help to see if they've got examples of this. But the more you do it, the better you'll get. But like I say, if you're just doing these 6 stages, you should be along the right lines of picking up some marks. Because again, it's better than to pick up 1 or 2 marks than to pick up none at all.